All right. Good morning, good afternoon, good evening. This is Mike from Unknown Tech, and welcome to the Architect Podcast. So, this was an impromptu podcast, and I'm actually glad that I actually did this because I'm excited to talk about the next subject. I know it's been a while since I've had a podcast. I've been crazy busy with work, travel, family, et cetera, et cetera, life in general, right? But I again around the holiday season, I tend to start picking up more, doing more content, creating more blog posts, and you can see I'm starting to ramp that up again as we go through the holiday season. Through the holidays, around before Christmas or during Christmas week, I probably will do the updated home lab um, video, and it'll be posted on the YouTube channel. And you can see what the home lab looks like. It hasn't changed much since the last lab, and I don't know if you recall the last time I did this, I actually went through and said, "Hey, I'm not going to buy anything for the foreseeable future," and uh, pretty much I didn't. I actually just replaced some drives on my NVR because I had to, because the drives that I was using were failing miserably. And so I bought some AI Seagate drives, but we'll talk about that in a later episode. Before I start here, I just want to point out that I am streaming to LinkedIn and YouTube as usual. LinkedIn will not have the ability to chat, but on YouTube, you will have the ability to actually chat and have comments, and I can answer those. There is a delay, there's about a minute delay between my stream and what you're seeing on YouTube. So if I don't respond to you, if you have a question, it's not that I'm ignoring you. There actually is this delay that I use because I use Restream to actually stream to multiple platforms. Another thing too is if you do want to join the YouTube session versus the LinkedIn session, the link is right on the screen in the white text below. And what I've noticed is that YouTube has pretty much better quality of stream than LinkedIn. And of course, YouTube's been doing this for years, and they have pretty awesome technology. And I'm not saying LinkedIn doesn't have technology, but YouTube has been doing this for years, and so you will get a better quality stream when it comes to the stream on YouTube. So if you want to just go to that, you have that link right there. I'll leave it up for a few seconds. Now, before we get into the subject of today's episode, which is really focused on building your own AI for your home lab, right? And we'll get into components, and we'll talk about what I use and all the choices that you can make. And then we'll end it with what I use for AI services. And we'll bring it all together right at the end and say, okay, well, what do you use this for? Do you use hybrid services? And the answer is yes, right? I think, this idea that you're going to pick this one AI solution and say, oh, this is my solution and I'm going to use it for everything, it's just a fallacy, right? I think there's so many different services out there that do things very well. I'll give you an example. Voice services from 11 Labs is phenomenal. I'm not saying you can't build this on-prem or do it in your home lab. You certainly can do that, but 11 Labs definitely has a pretty good entry-level plan for demos and testing. And there are other services that I use, like, I use Warp, and I have for my terminal, and we'll talk about the power of Warp in a little bit. It's very, very powerful, probably the best terminal I've ever used. And then, I use Perplexity from an overall, service perspective, for, general reasoning, asking questions, having them build content, things like that, right? So, Perplexity is great. It does phenomenally well. People always say, well, why don't you use ChatGPT? I have my own personal reasons behind that. I'm not going to get into that, but the reality is you have other options out there besides ChatGPT that you can leverage that are very good, including Gemini, right, from Google. I know Gemini 3, I think, just got released from Google. It's pretty powerful. Of course, Anthropic has Claude, is another phenomenal service, right? These frontier models I'm talking about do very, very well. And I'm not saying they're very close to one another, but they're kind of, right. They're not that far away from what you can deliver on each of those models. And of course, you have Grok from Twitter too. Or excuse me, from X. I didn't really talk about that too. But again, if you think about it, if you sign up for all these, it's almost like your television plan, right? I mean, at some point, you're going to get to a point where, oh, this one does better than this for this use case, and now I have 10 subscriptions, and I'm spending $300-400 a month on AI services, which is again, you have to control costs. Obviously, this is different than work. Again, I want to separate this episode from a lot of the episodes I've done when it comes to enterprise AI solutions. I've talked about NAI, I talked about N8N, right? All these solutions that I use in the enterprise, and we talk about for the enterprise, but I'm talking about what you can use at home today, right? And those aren't replacements for those things, by the way, right? You're not going to bring in Nutanix Enterprise AI as an example into your home, or you're not going to use N8N with the fundamentally the full plan, right, where you're paying astronomical amount. You can use N8N at home, and I do use it at home, and I will be starting to use it more and more for agentic AI, for automating some things around my home lab. That'll be something that I'll be working on the next couple months. But what I'm talking about is using them like an enterprise solution or requiring enterprise grade capabilities for a home lab. Now I know we're kind of at the cusp of that, where people want remote access and VPNs and all of these things, but the reality is it's not as robust as was the robustness of an enterprise solution is not required in a home lab for the most part. As much as we like to think we have an enterprise solution at home, a lot of us try to do enterprise, or provide enterprise foundational features. That's okay, but again, there's a lot of money in enterprise solutions, right? You pay for that for a reason. And I'm looking at what you can build out in the home lab, what you can do locally on your PC, as an example. And we'll talk about all the options that are out there today to go through that. All right. Before I start, too, there's one thing I just want to talk about too is as you have the break for the holiday season, if you're interested in the UAP UFO topic, Prime has just released a documentary called Age of Disclosure. You have to pay for it. You can rent it or you can buy it. It's probably and this is a side note, it's probably one of the most remarkable documentaries on AI, or excuse me, on UAP, UFO, alien life that I've ever seen. And so if you have a interest in that subject, which obviously I do, it would behoove you to watch Age of Disclosure. I'm not going to give away anything that came out in the video because there was a lot of surprises that came out. I follow this topic very closely, and I'm not deep into it, right? But I follow it, and I generally speaking, there are probably 10, 20 people that are regularly talking about this subject, and I follow those folks, and I'm kind of up to date with the information that's come out. I watch the hearings at Congress and those things, but even I was surprised at some of the information that came out of that documentary. It's called Age of Disclosure. So if you have a chance and you have nothing to do this weekend, or you want to watch something, I know TV's been kind of horrible, even though there has been new releases like Landman, etc. But as far as the movies are concerned, it has been kind of a mixed bag, right? As far as what good movies are out there. But Age of Disclosure is fun. It's about over 2 hours long. Very, very good. Okay. So I'm going to just share my desktop here because I want to get into some of the things I want to talk about today. But I think we should probably, let me just make this notepad bigger. I hope you guys can see this. Yeah, that's big enough. So basically, I align things into 3 categories when it comes to home lab AI. Okay, so you have used enterprise hardware. Okay, you have purpose-built platforms. You have commercial, not enterprise grade hardware. Small form factor systems, which I focus on a lot, although there is a trade-off, and we'll talk about that in a minute. And then you also have external AI services or hybrid AI services. So I think like this probably is a pretty good list to where we're going to start. I want to start really on use enterprise hardware. So, and you can mix and match commercial and enterprise, by the way. So, for example, you can have a Intel Xeon or AMD EPYC platform. I personally have a couple AMD EPYC platforms, 64 cores, half a terabyte of memory. It's an older generation. It's the previous generation of EPYC Milan, so I can run. So I have to use DDR4. That's one of the downfalls, I would say, from AI. If you're going to use CPU based inferencing as an example, although I try to stay away from CPU based inferencing for the sheer fact that what I do really requires GPU based solutions. And so in my home lab, I run Nutanix holistically from an enterprise hardware capability, right? And that's down on a rack. I've showed you guys that rack in previous videos. I'll do an update again this holiday season around Christmas time, New Year's time, to show you exactly where I'm at. But essentially, it is enterprise grade. It's an ASRock rack. So let's just go and look and see what I actually use. So I basically went on eBay when I bought this. So let's go to eBay really quick and see what this is. So I have ASRock rack Rome 82T. Let's see what those prices are right now. So, these are pretty expensive. I didn't pay $600 or $700 for this motherboard. But the reason I bought this motherboard is obviously, I like EPYC. There's more cores, the better for me. I have two single servers, two Nutanix servers, and I have populated half a terabyte of memory. It's DDR4 3200. The memory bandwidth isn't great compared to DDR5 platforms. The problem with DDR5 is it's so expensive, right? RAM right now is atrocious. So RAM has tripled in price since October. And so there's a shortage of RAM, of course, due to flash, due to the AI boom, right? So and of course, there's other reasons, right? Tariffs and things like that, what people will talk about. But the reality is there is a DRAM shortage, okay? And that will fundamentally tie into RAM prices, which is happening now. And like I said, RAM has pretty much tripled, quadrupled in price since October. It's crazy right now, even for commercial desktop RAM. Okay, now this is ECC memory, right? Registered memory, and I use 32 gigabyte stick, or excuse me, 64 gigabyte sticks in this platform. That gives me 512 gigabytes in the platform. But what I love about this platform is the amount of PCIe slots that I get, especially with the AMD EPYC 64 core CPU. Now, I didn't buy a retail part. Okay, so again, this is pretty expensive. I think I paid maybe $450 for my motherboards at the time. So it looks like hardware right now, it's not really a great time, unfortunately, to be buying hardware, especially RAM. And flash will start to become more expensive. I think if you need flash drives right now or anything flash, you should buy them now. But essentially, what I did was I bought this, and then I bought a AMD EPYC Milan 64 core engineering sample. So you have to be very, very careful about engineering samples. See, these prices are crazy. I want to say that I spent, here you go, $950. I spent less than that. And I don't buy from China, so that's another thing. And guy, this is my personal preference. Don't take this the wrong way, but I don't buy anything from China. I try not to. Of course, it's very difficult because a lot of things are made in China. But when it comes to technology, right, and those things, I try to stay away from Chinese brands. It's very hard to do, though. I digress. But really, I didn't pay $950 for my EPYC Milan 64 core processor. I want to say I spent about $700. So I think I spent $1,100 for the CPU and the board. And then the RAM, right? I bought used, of course, DDR4 ECC registered, 64 gigabyte. Let me go put the speed here, 3200. Yeah, you can see how crazy this is. I want to say I spent less than $200 per 64 gig stick, or it was like $220 a stick, right? So you can see the RAM prices are atrocious right now. So when it comes to enterprise gear, it's right now, I think I would stay away from that right now, right? Unless you plan on doing CPU inference, you really don't need 64 cores. I use my systems for many other things other than just AI, right? So I use it to run all the Nutanix capability, workloads, right? Demos, databases, everything else. So it's not just AI, right? So it's not purpose built just for AI. It's purpose built for Nutanix and workloads to demo Nutanix and all of those things, right? So it's being used, right? As a matter of fact, I'm almost out of memory on one of the nodes right now, and that's due to a lot of Kubernetes, right? A lot of databases, things like that, right? So if you plan on doing CPU-based inference, people will say go with the latest, Epic CPUs with DDR5 memory, or you can even go with the Threadripper system. But even Threadripper is expensive. So if I go to Threadripper, and let's go to here, what we'll do here is we'll go to Newegg here, and we'll go to Threadripper. And I looked at Threadripper too. Even the 7000 Threadripper, which is previous gen, is still expensive. All right, so this is a 32 core for $24.99. I mean, you can get Epic Milan 64 core for, $900, right? Engineering sample, probably less if you keep on looking on Newegg. Now, but this is the new Threadripper processor, right? This is the 9000. Very, very. Look at the 64 core, $8,000, right? Now, if I put this 64 core up against my Epic Milan 64 core CPU, I'll get trounced, right? From a pure IPC perspective, there's not that big of a gap though, right? And so that's why I say, why would you spend like $8,000 on a Threadripper CPU when you can just go get an Epic Milan CPU for 64 core? And people will answer probably. People will say, oh, well, I need the high clock speed, because you could get very high clock speed out of these CPUs today, right? The 9000 series. But you don't need that, right? You don't need that at all. You don't have to go enterprise gear. So another thing I did was I also bought on eBay for this Epic system, and we'll finish this up here in a minute here, but I want to get to the other systems, so I think they're more realistic. But I also bought an NVIDIA L4 GPU, and these are expensive right now. I can tell you I spent, I want to say $1,700 on mine. So everything's like very, very pricey right now when it comes to GPU, especially for AI. So the L4 has 24 gigs, right? It's a very capable GPU for its size, for what it does, and I'm able to do a lot of things with it. Of course, the 24 gig is the limiting factor, but you have to compare it. Like, what are you gonna get out of it? And also, the limiting factor is bandwidth, by the way, because you can tell here, there's no active cooling on the L4, even though I'm in a server and I have fans blowing air across it, right? I also have a fan laying on top of this and my add-in card for my NVMe drives. And by the way, I just bought a 4-port NVMe card, Gen 4, right? PCI 16. And I have 4 terabyte HPE NVMe's that were on sale. And those were, I want to say $200 something. Now you can't even get a 2 terabyte for $200. It's crazy, the amount of the prices right now. So, the L4, do you need it? No, you don't need it. You don't need an L4, right? You don't need a RTX Pro 6000. Everybody's like, I want to get this RTX Pro 6000. And I'm looking at some of these people and what they're doing with it. And I swear it's like forgive me for saying this, but it's like e-penis, right? It's like they're bragging about their e-penis. That's what we used to call it, right? When people will come on and say, I can get so many tokens per second. So what? What is that? What are you doing? What are you trying to use it for, right? What's it matter if you're not talking about a use case? Everybody's on, Reddit, on the local AI or local llama forum, subreddit, talking about how many tokens per second they're getting, how wonderful it is, right? All this stuff. Half of them don't have, the NVIDIA enterprise licenses to take advantage of MIG. Like no one's using I wouldn't say no one, but a lot of people aren't using their solutions like they should be using it. So why spend all that money? It's $8,000 for an RTX Pro 6000. By the way, I think that's a deal for what you're getting, but for a home lab, $8,000, that's crazy, right? So, you don't need to do that. You don't need to go, to 24 gig, an L4 either, right? Which is an enterprise. It's an edge solution, right? AI solution, but it's an enterprise solution because of, look at it. It's $2,300, right? Why do you need to spend that? You don't need it. You can get 3090's 24 gig for $600 a piece, right? Now, the difference is, okay, well, I can put this in a smaller form factor, right? But those are the trade-offs I'm talking about, right? You can get two 3090s for half the cost of this, okay, and have 64 gigs of very fast GDDR6 memory, okay, that will provide you very good inference performance, right? And decent model size. And I think that's another thing everybody talks about is I want to run the largest model. Why? Why do you want to run the largest model? Give me a use case why you want to run the largest, because there are SLMs and quantized models that do fairly well today, right? Fairly well, not as good as the big model, you know, not quantized, but decent quants on larger models to fit on GPU memory like 64 gigs or 24 gigs. You can get pretty good performance. Like I run GPT OSS 20B on my L4, no problem. It runs great. I run it on my my RTX 4000 SFF Ada GPU, which we'll talk about in a little bit. But it does fairly well, right? But if you obviously, it depends on what you're using it for, right? And what models you need to run. And so I think it's really important that you understand your use case. Just like in the enterprise, use case is number one to determine the solution. The same thing in the home lab, right? Because we don't have infinite budgets. We have, in fact, very low budgets in the home lab, right? For the most case. And we're trying to squeeze as much performance and capability out of those budgets as possible. And that's what you should be focused on, not focused on, oh, is my EPNS large enough that I get, so many tokens per second, because that doesn't mean anything, right? When people talk about that in Reddit, I just ignore it. Doesn't mean anything to me. Okay. All right. So that's kind of what I run. This is kind of some of the things you can get. You can look at L40Ss now. I don't know how much they are now, right? 7,000. So they're still up there. Just, why buy an L40S at 48 gigs of RAM for $7,400, $7,800 when I can buy an RTX Pro, right? Blackwell 6000 that has 96 gigs of RAM, right, for the same price or close to the same price. To me, I think this is ridiculous that these are even up here at 78. These really should be more like $3,000-$4,000 at this point, since the Blackwell 6000 has been released. Okay, and by the way, the Blackwell 6000 comes in 3 different variants. Okay, it comes in Enterprise, which doesn't have active cooling on it, right? Looks like this a little bit. It comes in Workstation, okay, and it comes in Max Q, okay, Max Q, which is a 450 watt variant of the Blackwell 6000 to save on power and cooling, okay, and it does pretty well. Now, I don't have RTX 6000s, right? So I couldn't tell you the performance benefits, but if you go to like Level 1 Techs on YouTube, Wendell will go through and walk through the difference between the Max Q and the 6000, regular 6000 workstation. And there's a difference, obviously, but it's not that big of a difference. And you're saving energy, right? And you're saving electricity, right? So electricity costs and heat, right, are very important, especially in servers, especially within smaller servers. So, for example, you could even take a 6000, regular 6000 enterprise, and you can limit it to 450 watts as an example. You could do that too, right? You can do a limitation on that as well. Matter of fact, some vendors actually do that, right? When they stack in, many 6000s together, they're trying to lower the wattage, right? They're trying to lower the heat dissipation, and they're still getting phenomenal performance. Okay, so yeah, L4, so I think as far as enterprise gear right now, I would hold off on that, right? Unless you can get a phenomenal deal, and you're doing GPU inferencing, you can stick with Epic, you can stick with last gen, right? If you're doing CPU inferencing, I would go Intel all the way. And people will probably cringe when I say this, but I would go Intel, and I would go newer Intel or Intel with AMX extensions, because now I have the ability to offload some of the inferencing capability onto AMX using AMX extensions on the Intel CPU. And so I would personally try to get an Intel CPU that supports AMX if I was going to do a home lab today just for AI. Okay. I can brute force Epic, right? But it's not as good as the obviously the offload capability that Intel has in some other newer CPUs, right? Xeon CPUs. Okay, so that's it for that. I mean, as far as connectivity, it's just 10 gig right now. I do have the capability of adding a 25 gig, and I have a 25 gig ports open on my Unify aggregate, or excuse me, Unify Enterprise XG switch. I have two 25 gig ports that are unused. So I could use that, but I wouldn't get any benefit unless I had one server connected and then my workstation connected, right? Or something, right? Where I was, doing the inferencing against, right? Where if the application was either on the server or on another server that had 25 gig, right? So, or the data was being fed remotely, right? From a storage device, a SAN or a network attached storage device, right? Honestly, for what I do, 10 gig is fine right now. I probably will go to 25 gig eventually, but just not right now. Okay. All right. So, what other things can you do? Well, let's go back to this list, right? So, we really covered kind of some of the enterprise gear that I use, and you know, I just think let me just italicize this because if I italicize this, hang on, make it look like we actually. Oh, okay. So the italicize means that we went through it. So now we're going to talk about purpose-built platforms. So there are many different purpose-built platforms, and they actually tie into SFF systems as well. But all you hear people talk about today are two different platforms. Not all, but mostly. So you really have three options here, okay, for purpose-built platforms. Now, one is purpose-built. The other two can be used for AI. Let's just call it what it is, okay? The first thing everybody, all the rage right now, and everybody has been talking about this, is the NVIDIA DGX Spark. Okay, this is basically a purpose-built small form factor system that runs the NVIDIA GB10 Grace Blackwell ASIC, and what it is it's a combination of 20 ARM Cortex cores. Some are high frequency, some are low, right? So think of big little design, right, around ARM. And it comes with 128 gigabyte of LPDDR5X unified memory. So you can load large models into this platform, okay? Comes with 4 terabyte NVMe. This is the NVIDIA version, right? It is a smaller NVMe, right? It's the small form factor NVMe. So you're not getting the full capability of NVMe because of small form factor. That's one thing I think that they could have done better, especially for the price. But what it also comes with is it comes with 10 gig network, Wi-Fi 7, and 200 gig ConnectX networking. All right. Now, you're probably thinking to yourself, why the heck would I need 200 gig ConnectX networking in a ARM box, right? With a smaller Blackwell? Because the Blackwell system, the GPU is pretty phenomenal for what it does, especially with floating point 4 performance. It's pretty capable. The big issue I have with it is the memory bandwidth. It's horrible. You're using LPDDR5X, right? And current GPUs are using DDR7 or GDDR7, right? And the bandwidth of even a 3090. Matter of fact, my RTX 4000 SFF Ada has better bandwidth than this system. Now, does it beat this system? No, because this system has twice as many next gen tensor cores, Blackwell tensor cores, etc. Right? So there are other things obviously that make it more capable. But if you took a 3090 up against this, yes, the 3090. I know you're thinking, well, the 3090 only has 24 gigs of RAM. This has 128. I get it. But if you take a language model that fit in both, okay, and did a benchmark, the 3090 would eat its breakfast as far as tokens per second, time to first token, et cetera, performance. All right, and cost a hell of a lot less, right? So I can get a 3090 for $600. I can get two of them, gives me 48 gigs of RAM, right, for $1,200. And here we got $4,000 for this. Okay, now you can buy different. There are different models that you can buy. You don't have to buy the NVIDIA one. The NVIDIA one's $4,000. The NVIDIA one's $4,000 because I believe they say because of the 4 terabyte NVMe. But you can buy the Asus. Lenovo makes one. MSI makes one. A bunch of them make one. You can see the prices are better, but this only comes with 1 terabyte, right, of NVMe. But it's the same chip, same capability. same connectivity, still get the 200 gig networking, 10 gig networking, etc. Now you can combine two of these, and that's really what the 200 gig networking is for, right? To make a cluster or combine three and daisy chain, right? The connect exports. So you would go 1 to 2, 2 to 3, 3 back to 1, right? And that because you have dual ports on each one, dual 200 gig ports, right? So you can make a 3-node cluster, right? Just daisy chaining, and get extremely high capability when it comes to FP4 performance, inference performance, and very large models. Some fine tuning, some training. Now, would I train with this? Would I fine tune with this? If I was a developer, yeah, I mean, that's what it's geared for. I think that's another thing we have to talk about. What is this really geared for? Is it geared for the user to use in production? No. This is really geared for the AI developer, right? And what does that mean? That means testing, validating AI apps against inference, different model size, different model types, fine-tuning models, training models, right? But they don't care, particularly about, massive performance, right? So I think, this could be an option. If you're an AI developer, this is probably a very good option for you, right? And I would pick the NVIDIA one because of the 4 terabytes of NVMe. And plus, it's just so cool looking. Let me look at this thing. It's gold, right? And I know that's kind of like off topic, but it's just so cool looking, right? So that's the NVIDIA pre-built systems. Now, there are two other systems that you can leverage, right, for AI that are not purpose-built really for AI, but can be used for AI. The first, everybody's talking about this one too, is the Framework Desktop, okay? Now, this is based on AMD's Strix Halo design, okay? And it has 128 gigs of memory as well. Can you use all 128 gigs? The answer is no. You can get up there though, right? To leverage it. Now, there's this big back and forth between how good these systems are, right? Like if you were to compare a Framework against a Spark, there are two things I think that stand out between the third one, by the way, and we'll get into it, is a Mac, right? You can buy a Mac M3 Ultra with 512 gigs of memory and great memory bandwidth. The problem with both the Mac and this system, right, is it doesn't have a CUDA-like framework. Okay? Now, I know I'm going to get bigots on here to come back and say, oh, my Strix Halo is awesome. I can use the Vulkan API. I can use the ROCm API or ROCm framework, right, for AMD. Mac has its own. I don't really know Mac. I know Mac has its own. There's another YouTube channel. The guy's name is Alex. Hang on, I'll just go to it. I really love his channels. They're great. Alex Ziskind, I think. He's phenomenal. He tests all these things, right? And he kind of gives you like this no BS testing. Now, is this testing really for real use cases? I mean, not really. I mean, he's really talking about, I can get so many tokens per second, time to first token, those how big of a model I can fit. I mean, those are important depending on what your use case is, like what's your use case calling. But for a home lab, is it that important? I don't know, right? Maybe it is, maybe it isn't. But you can go to his channel. You can get a lot more information, especially about the Mac. But I want to talk about the framework. I want to go back to the framework in the Mac really quick. Okay. The great thing about NVIDIA is the shit just works. Okay. I'm not having to do anything special so much to get it to work, right? It just works. And the reason why it just works is because of CUDA. And people can argue with me about this, but the reality is the silicon's phenomenal and the frameworks in the back end are phenomenal, okay? And NVIDIA knows this. It's the reason why all their stuff is so expensive, okay? It's the reason why that the H200s and the H100s and the RTX 6000 Pro and the NVA AI license required for those GPUs is so friggin' expensive because they know they have a leg up on AMD. They certainly have a leg up on Mac, and they certainly have a leg up on Mac doesn't even have an enterprise solution, and they certainly have a leg up on Intel, right? Intel, and we'll talk about Intel in a little bit, but Intel has some capabilities too. So what is the framework? The framework is cheaper but not by much. So let's go look and see how much this is, right? So you saw that the NVIDIA Spark for the 4 terabyte model, it's $4,000, okay, before tax, shipping, etc. For the Asus version, it's $3,000, but you're only getting 1 terabyte of NVMe. Okay. Now I know it doesn't take $1,000 to get to 4 terabytes. You can probably upgrade the Asus, save yourself, $600, and spend $3,400 on the Asus model and get 4 terabyte. Right. That's something that I would do personally. I wouldn't buy. The NVIDIA one is nice because the gold, and I think it's one of those things that you'll keep, and it's like one of those things that it's NVIDIA, right? It's NVIDIA branded. But if you're cost conscious like me, I would go for a different model that's cheaper, where I can upgrade the NVMe myself and not spend the extra grand that NVIDIA's charging. I mean, NVIDIA's charging an extra grand because it's gold color, it's NVIDIA name, and it's 4 terabyte NVMe, right? Let's go back to the Strix Halo really quick. All right, so you had the option 3 here, which would be the option for AI. You could get away with both of these, right, for AI. But, I mean, to compare against the Spark, right, this is pretty phenomenal. Now, what I will say about the Strix Halo is if you want a system that's small form factor like the DGX Spark, okay, but will not just use it for AI, use it for other things like gaming and other things, then this system is great. Right, because I can game on this. I can do 1440p gaming on current titles with the integrated iGPU, the A60S. It's phenomenal. All right, but what the NVIDIA Spark lacks in performance on gaming and those things, right? And the fact that it's ARM, right, and it lacks in obviously interoperability. The ability you can't run Windows games, or it needs an ARM Linux, right? It's not x86. The 395 is x86, right? And I can run all of my applications that are compatible with x86, and I can still run AI workloads, okay? It is lacking in the bandwidth, right? It's only 5 gigabit Ethernet. It does have a by4 PCIe slot, I want to say. I don't know if it's a by3 or it's a by4, but I don't know if it's Gen 3 or Gen 4. I can't remember. Let's see the full specs. I don't even think it lists it. This one has 2 NVMe ports, right? The other one doesn't. Like the DGX Spark doesn't. It only has 1. It has a 5 gigabit Ethernet. Yeah, it has a PCIe by 4 slot, not exposed in the case. You can buy the motherboard by itself without the case. So if you use this case, you won't be able to use the by 4 slot. Well, you could add 25 gig networking if you wanted into this with the by 4 slot. That's one thing you could do. But it's not 200 gig networking, right? It's not like the NVIDIA ConnectX system, right? Backend. So that's the other thing is the framework, right? You can buy the motherboard and build your own system, or you can buy the whole framework desktop that comes with, you decide, right? You can piece it together. You can have framework provide all the NVMe. I wouldn't do that because you're going to spend more. Anytime you have custom integrators provide you, NVMe, RAM, etc., you pay more for that. You're better off just buying it bare bones and you install it, buy it yourself outside of that and install it. There are other AI 95 systems, 395 systems, Ryzen Max. One of them is the B-Link GTR9 Pro. I love the look at this. It looks like a Mac. One thing I really love about the Mac is their form factors and what they look like. I love them, right? No one's been able to kind of copy this, but I got to say, B-Link came close with this device, right? And it's pretty awesome device. Again, 395 CPU, same as the framework, 120 gigabytes of RAM. You can upgrade the NVMe drive. This one comes with 2 terabytes. Comes with dual 10 gig network capability, etc. And you see here DeepSeek 70B. You can run DeepSeek 70B on this platform, no problem. But what I'll tell you again is you're bound by the bandwidth as far as performance is concerned, right? Again, the DGX Spark memory bandwidth, not great. The memory bandwidth in this is probably a little worse since it's not unified memory. It's not really true unified memory. LPDDR5X again, right? And until we get systems like in this form factor that can take advantage of, GDDR, so unified memory, DDR7, etc., the Mac has phenomenal bandwidth. The problem with the Mac is the back end, right? The frameworks to support AI. Okay, that's the problem. All right. Okay, so again, we talked about the Mac a little bit. I won't get deep into it, but that's another system that you could leverage, right? And again, you can choose your Strix Halo system. There's another one, GM Tech, I want to say. GM Tech, Mini PC, GM Tech, Strix Halo. I know it's in here. The search on Amazon Prime is horrible, by the way. You probably already know that. Okay, so those are kind of talking about the purpose-built systems. I know I'm going long here, but let's just italicize this to say we reviewed this. That's part of the small form factor systems, but I want to talk about what I've done here internally, what I've built. But I want to talk about commercial grade hardware. So you can do commercial grade hardware. So for example, my system, okay, right now, right, is a 9900X. I have a 9950X 3D that I need to replace with this system, right? I sold my 9900X. I actually have to, after this podcast, take my system down and install the 9950X 3D, and so I can ship out the 99X. But you can see here I have 128 gigs of RAM, and I have an RTX 5090. Now, it's multi-purpose. This is my workstation. I use it for everything, okay? Work, development, tons of Kubernetes stuff. I'm always doing AI stuff. I'm always using it for AI, whether it's for Visual Studio Code locally, Olama, LM Studio, just a bunch of different AI tools that I'm using. And so I have an RTX 5090. Now, an RTX 5090 right now is around $2,400 or $2,600, and you get 32 gigs of very fast GDDR7. It's extremely fast. It's 32 gigs, so it's more memory than the 4090. 4090 was 4090 was 24. The 3090 was 24. The 5090 is 32. Okay. What I would recommend is if you don't need like the fastest, so I game too, right? So I want the fastest frame rates, and so I use it for everything. So I splurged on this system to be the top of the line, basically desktop grade, not enterprise grade, right? Solution, right? 9950X, 16 cores, 32 threads, X3D processor, 128 gigs of RAM, RTX 5090, and I have about 8 terabytes of very fast NVMe storage. Okay, all Samsung. One is Gen 5, one is Gen 4, right? Very, very fast. This system just rips through everything I throw at it. What's lacking is the memory size. We talked about this, right? But I don't need it. I'm not trying, like I said, I'm not trying to run deep. First of all, I would never run DeepSeek or Quen or even Kiki KM2, what I think it's called. I'm just not. I stay away from that. I worry about bias, what's in the code, what's in the model, etc., because it comes from China. I'm just worried about those models, so I don't use those models, right? But I try to use models like GPT OSS, Mistral, Llama. I try to use those types of models locally, and I'll use I'll test different models, right, for coding. Visual Studio Code. We'll talk about some of the tools I use in a minute, but Visual Studio Code I use a plugin called continue.dev, and I tie in my Llama instance, model instance into the continue.dev, and that way I have my own Copilot without paying for GitHub Copilot. Right now, is it as good as GitHub Copilot? No, it's not as good, right? But it does the job. Okay, and so I'm not paying for a GitHub Copilot subscription, and therefore I save on that. Although you can say, well, you spent all that money on the RTX, but I'm using the RTX 5090 for all other things, right? For gaming and everything else, right? So this is the workstation that I created. It's a very, very robust workstation, and it works phenomenally well. And talk about multitasking. The 120 gigabytes of RAM is phenomenal. It's DDR5 running at 6,000, right? Mega transfers, but it's not GDDR7, right? and I'm not getting bandwidth like that. But I don't run models on my CPU, and I don't inference or any of that. So the memory that I have in my system, while it's important, right? It's not as important. Okay. Um, and so that's one part of it. It's very, very capable. Okay. Now, if we go back here, there's other hardware you can buy. Okay. You can go all the way, you can go and buy, a B650 Ryzen system or a Z69. I would stay away from the latest Intel Z890 platform. I think the 200K series Intel CPUs, they have no hyper threading. They're worse performance than the previous gen. If you're going to buy Intel, I happen to like the previous gen Z690, Z790 chipsets, and the 1200 series and the 1300 series. The 1400 series, high end, from my understanding, it is not great. It actually degrades over time. So the 14900K has problems with degrading. Matter of fact, there are other YouTubers that I've watched where they've lost CPUs from degradation. And so I would stay away from the 14900 series. By the way, Intel is releasing a new CPU on that platform. It's coming. I think it's 12 cores, 24 threads, and it's going to be very high. But it's built really for gaming. So you can build a very capable system on a budget, spend less than $1,000, and then go buy yourself a 5060 Ti, 16 gigs, right? And still be very capable from a AI perspective. Yeah, 16 gigs I know is small, but for the price and what you're getting, I think it's fairly good. You're getting CUDA capability, you're getting tensor offload, all of that capability. So even in NVIDIA's desktop cards, GPUs, you're getting the benefits of the enterprise GPUs on those desktop components, right? And you're getting very good, very fast memory bandwidth, etc. Right? Or you can opt to go for an older card. So I know some people that have purchased older Threadripper just for the PCIe lanes, right? Because if you buy like a desktop board, an 870 from AMD or a Z790, right, you're going to be bound by limited PCIe lanes. So if you want to have multiple GPUs, you want to be able to have support those multiple GPUs and get the full PCIe bandwidth. And so what we'll see is people will go out and they'll buy older AMD EPYC like I did, or older Threadripper, get the PCIe lanes, and buy a couple of used 3090s and in a decent beefy power supply, right, 1200-watt or higher power supply, right, as an example. And what you get out of that, like I think I talked about this before, is very capable system, right, at a very reasonable price, and the ability to run models that can support 48 gigs of GPU memory. Okay, so you have the ability to do that, and go look for solutions like that. Go on the forums, go on Reddit. Buy used, buy from a reputable trader, and buy used. There's nothing wrong with that. I see people all the time, they avoid used hardware. I've been buying used hardware for the last 15 years, 20 years. Okay, and have I had problems? Probably 98% of the time, 99% of the time, it's fine. Do you run into a problem occasionally? Certainly. That's why you use protection. That's why you use PayPal or a payment solution that provides you protection, where you can actually file if you need to file. And I've never had to file a complaint against the trader on PayPal to get my money back. I've had to give bad reviews, but I've never had to file a complaint to get my money back. So there's nothing wrong with buying used gear. Nothing wrong with going on the forums. Generally speaking, you'll get better prices than eBay on used hardware. If you go to like Reddit, Hardware Swap as an example, or Home Lab Sales, or if you go to Hard Forum for sale trade, right? And you buy from a reputable trader, right? People that have references, right? Heatware, eBay, refs, things like that, right? So there's no reason why you can't do that. So you can use commercial hardware, no problem, and still have an AI platform for your needs. So I like SFF systems. I like small form factor systems. And so what I did was I actually built a system. I call it the do-it-yourself DGX Spark. And if you go to my website, I have a blog called Unknown Tech IO. I actually show you the system that I built here to the right. And essentially what I have is I had a mini swarm AR900i motherboard that I was going to use for a NAS about 2 years ago, year and a half ago. It didn't work out, and so it was still in the box. It had 96 gigs of RAM with it, and so I just built a 3D printed case, right, that someone had built already. And I bought actually I didn't buy anything. I already had everything. I basically used an RTX 4000 SFF8 that I have been using for testing. I've had that for 2 years. I've put that in the box, and I installed Ubuntu Linux on it, 2404. And I walked through the process of what I did in part one, right? What I used, right? And basically what I did was I tried to make it as close to the DGX Spark as possible. Obviously, the big trade-off is the VRAM, right? I will only be able to use 24 gigs of memory, right? And the VRAM on obviously the DGX Spark is 128 gigs, right? So the size model that I can support is not the largest, but I can support pretty good models, reasoning models, GPT, again, OSS 20B, etc. And so I installed all of the NVIDIA components on the solution. And here it is right here. I'm using my Jet KVM to actually connect. I don't have SSH configured in this yet. You're probably like, you don't have SSH, dude. But I haven't configured that yet. But I'm in the Spark now, or excuse me, my do-it-yourself Spark. And it runs great. I mean, it really does. And I have basically, let's see what I have running here. So if I go to Docker PS, I have Open Web UI, which is my UI to connect to the models. And I actually had the ability I have Olama installed. Right now I have 2 models downloaded. And I actually have my NVIDIA NIM NGC Docker login configured. And so I can download models for both Olama and NVIDIA NIM. Okay, so I have my API key configured. So I have my NVIDIA Docker Container Toolkit. I have NVI Top to monitor in real time the usage of my RTX 4000 SFF ADA, right? And I still get that. There's things I have to do in the command line. Don't get me wrong. Like for example, there's still things I have to do in the command line. So let's do this. We're going to start up a model in what's this? No, I don't want that. No. So we're going to start up a NIM model, and we're going to use Open Web UI. I don't know why I didn't have. Hang on one second here. It's easier for me to do this, believe it or not. Okay. Oh. Maybe that's something I didn't download yet. All right, just bear with me a second. So if I go to CD mount, this is where my models are located. I actually have a striped LVM for this. I'm gonna CD NIM. What's in here? CDNGC, CD Hub. Okay, so I have Gemma 2B. I have Llama 318B instruct. And I have this Nemotron. Yeah, I like that Nemotron model. That's that reasoning model. By the way, where you can get this is if you go to is it developer? No. NVIDIA NIM models. Build. I'm sorry. /models. So if you go to build.nvidia.com/models, you can get all the information of the models and how to actually install them and actually get them going. So what we'll do here is we're going to go back to my Jet KVM, and I'm going to run Docker run help. Able to find the latest locally. Docker error message name and pull access denied. Oh. Oh, that should work. I'm not sure why it's not working. All right. I guess we'll go back and we'll run the Olama models to make it easy. Let me see if I can run Gemma first here, though. There we go. Okay, so that'll pull. And then what we'll be able to do is we'll be going into Open Web UI, and we're going to configure pointing to that model. Now, you can use Open Web UI against NIM models, which I'll show you how I configured that, and you can use it against Olama models or even any Open API inference endpoint. So what I did here in the settings, though, I wanted to show you is I actually created a system prompt, and basically I wanted to show the model going through chain of thought process. And so I provided this system prompt, basically your logical system answering, show your step-by-step reasoning process, breaking down complex queries, and explain the steps, right? So basically I'm telling the model to go through its chain of thought and show me how it went through this chain of thought for its what I'm asking it to do, right? So anytime you ask it a question or ask it to create something or do something, it will automatically attach this additional system prompt, right? The context to allow it to go through the chain of thought process. The other thing that you do is you go here down to your login settings. I'm sorry. Go here, login, admin panel, and up to settings. Right. This gets a little bit confusing. Go to connections. So you can see here that I've added an Open API endpoint for Open Web UI to my DGX Spark, right? So I'm using the 8000, right? V1. This is my NIM model default inference endpoint, okay? And if I want to use Olama models, it automatically uses the Docker container 11434 because that's the Docker internal host. And because I'm running Olama on the same host as the Docker configuration, basically it just uses the internal host, right? So you have to actually set this up because this is not in here. So if you want to use NIM, you actually have to configure this connection here. Okay. So let's go back really quick to see where we are. It's downloading, complete, extracting. So it's taking a little bit to actually get this going. But essentially, that's how you configure Open Web UI for NIM models and Olama. Olama will automatically be configured, but the NIM model will not. You'll actually have to put this in here. You can actually go out to OpenAI as well if you have external access and connect to OpenAI models through the API, through the OpenAI API backend for OpenAI. So if you want to connect to GPT-4 or GPT-5 or GPT-5 mini or whatever, right? You're connecting to those models. Now, we all know that GPT-5 especially is not the model, right? It's basically a router when you think about it, right? Because it's going to point you to the right, depending on what you're asking, it's going to point you to the right model for your inference. I think a lot of people probably don't know that, but people say, "Well, GPT-5 is the best model." It's not. It's not just one model. It's a mixture of models. Okay, depending on what you're asking for it. But you can actually connect to any OpenAI API endpoint, to including Nutanix Enterprise AI. Now you won't use this. You could use this for testing, which I like. One thing I like when we test out the Olama models is I'll be able to get metrics. For the OpenAI models, I actually have to have open telemetry or some of those frameworks set up that feed into something like Grafana, so I can get those metrics out of a third-party system. Within Open Web UI for Olama, I'm already getting those metrics. There isn't a way, I wish there was, to configure the OpenAI models to get the metrics like Olama models. Unfortunately, you actually have to use a third-party tool like OpenTelemetry with Grafana to get those those metrics. All right, let's go back here and see where we're at. Let's do a Docker PS. Let's look at the logs and see if it's ready. don't know if it's going to be ready yet. Let's see. Nope, not ready yet. If it was ready, it would show up in this list. And it's not ready yet. All right. Workspaces. All right, there it is. So you see Gemma's up right here. Tell me a quick, funny story. One thing we can check out is the NVI top. You can see here the model's loaded in GPU memory. You can see the temperature, right? How many watts is being used. I don't think it's quite ready yet. Let's see if it's ready now. Yeah, it should be ready. Oh, error in applying chat template. I'm not sure why I'm getting an error. Let me just look at something. Still the same IP address. It's running. Okay, so I'm not sure why that's not working, but what we're going to do here is we're going to stop this. We're going to stop and remove it. I'll have to double check this. This worked last time. I'm not sure what was going on here. Okay, that's done now. So let's fire up the llama. We'll fire up the GPT OSS. Yeah, so that's already up. Let's go back to Open Web UI. And you can see here it's green. This is one thing that you get within Open Web UI with the llama is you'll get a real state, right? So it's green, it's up, it's working. And let me do a new chat. We'll delete that. Tell me quick story about AI. Okay, so you can see here, here's the chain of thought I was talking about, right? Now this is running on my RTX 4000 FF Ada, right? So again, it's a very small form factor system, sits in that little cubby. I have a Jet KVM connected to it. It's only connected to 2.5 gig networking. The storage is internal, so I'm not servicing models or storing models or other things externally. So it's all internal over the PCIe bus, so it's very fast as far as loading. And you can see here, it gave me the chain of thought, and then it went through and gave me a story here, right? And again, you can go in here and you can go back and look at NV Top, and you can monitor the utilization, the wattage, right, the temperature, how much VRAM is being used, what processes are leveraging the GPU, right? So obviously my display, right, the display here for Xorg VT2. And then, of course, Olama has almost 12.5 gigs loaded into that GPU, right? So that's one thing you can do here. Now I can do a llama stop. That'll stop the model. Okay, so that's not running anymore. I don't know why my NIM models aren't working, but essentially that's kind of, how I use this, quote unquote, for lack of a better term, a do-it-yourself DGX Spark. So this cost about, I want to say, a little bit close to $2,000. Okay, so if you look at the Asus, right, with the same amount of NVMe, you're probably going to be about 3,500, 3,600. You look at the DGX Spark, from NVIDIA, you're looking at $4,000, right? So roughly, uh, you know, half the cost, right, of what I spent on this. Now, the trade-off obviously is I'm not getting all the DGX Spark tools that come with it. Like there's a remote tool that I don't have that you can install. And you're not really getting the DGX operating system. I'm faking that using Ubuntu 24.04 and installing the NVIDIA tools that I can install on the DGX Spark. And by the way, Perplexity helped me kind of build this, right? Outline, okay, how I basically said, how can I install or create my own do-it-yourself DGX Spark and get as close to capability as the DGX Spark as possible, right? And it kind of walked me through what I needed to do. The problem, of course, is yes, you only have a certain amount of memory, right? Sort of VRAM, right? You're getting 128 gigs with DGX Spark. You're not getting that with the do-it-yourself DGX Spark that I built. Okay. Again, it all boils down to what is it you're using it for. So one of the other tools that I use, and by the way, you already see me using Warp, right? You saw me using Warp in that KVM instance. I use Warp all the time, right? What I love about Warp is I can go to agent mode and ask it a question. Tell me why the NIM model didn't work. Let's see if it can go in and find it. So this is Warp. I have a subscription to this. Okay. What command did you run? Or if you have any logs, right? So basically, if I were to run that Docker command again, let's go back here. And we're going to start that. We're going to start this again. Okay, now that you know it's downloaded, it's already been downloaded, it's just going to run, right? So Docker PS, let's do Docker logs. That Numatron model is actually really good too, especially the 9BV2. Okay, so it's not there yet. No, I can't do that. Let's see what happens here. I want to see if it loads here. Oh, says here I'm using a deprecated PyNVML package. Please install NVIDIA MLPY instead and make sure you install PyNVML. Oh, and both of them are installed. PVNVML take precedence, cause errors. Watch this. I'm getting this error trying to run a NVIDIA NIM model. Nope. Even though it's not letting me copy that. Oh gosh. I have to use paste. All right, let's see what happens here. So this is going to actually tell me how to fix it, right? But I shouldn't do that with the Docker the Docker container running. Okay, so what I'm going to do is I'm going to reject this, and I'm going to go back here and do Docker logs again. Sorry. Okay, and I'm just going to go back here. I want to make sure that this is still not working. Yeah, it's still not working. Okay, so what I'm going to do is I'm going to unload that again. So I'm going to stop it and remove it. And I'm going to go here. I'm going to say the same question here. Now this is agent mode, right? So basically it's going to go through and say, hey, I'm going to create the command for you and go through this. And it's finding some other problems, right? I like how you're interacting with the agent, right? It's asking me questions. Anyway, it'll walk through the process of trying to fix it, which I love in Warp. So if you get caught on something and you say, hey, I'm getting this error and you don't know what it is, it'll walk through. Sometimes it'll log in, it'll do all sorts of things and check, especially on local systems, even remote systems, right? So I've had remote systems where they say, okay, your SSH into this, let me SSH, blah, blah, blah. It'll do the logs, it'll look at them, it'll monitor them, it'll kind of give you kind of an output of what's happening. And so it's almost like having like an SRE at your fingertips, which I love. Okay, so that's one of the tools that I use is Warp. There's also full agent mode where you can actually build code and all sorts of things, which I haven't really done yet. I still use Visual Studio Code. So if I go in here to Visual Studio Code, right, I have a plugin called Continue. And under this, I have a config file, right? So you have a local assistant, right, for Olama, right? So if I run Olama locally, so let's do that. Let me go into my Warp that's local. So I have GPT OSS 20B. Let's do Code Llama though. So let's do run Code Llama latest. It's going to take a minute to load. I can go in here and let me just I have NAI. I can choose local. It'll auto detect the model. All right. Okay, so we know that's working. Let's try this. I'm going to use Code Llama latest. Okay. So you can see here that I'm locally hosting on my workstation, right, using Olama, the models that I want to use, and I'm tying that back into Visual Studio Code, right, through Continue extension. And that way I don't have to pay for a GitHub Copilot subscription. Okay, so again, using the power of what I already have in my workstation to actually do coding and things like that. So that's another tool that I use. So you saw that I use Warp, I use Visual Studio Code with Olama, and other third-party tools I use. Perplexity. Let's go here. AI tools. So I have a subscription here. So generally speaking, I have 3 or 4 subscriptions for AI. I have subscription to Perplexity. This is pretty much what I use to do anything around reasoning, search, trying to walk through something, right? An architecture. I could use Warp to do some of that stuff too if I wanted. But I really like Perplexity and what it brings. It can give me diagrams, it can build me pictures, it can create content, it can do all sorts of things. And it also has a browser, right? So you've heard of, obviously Google has Gemini, right, in the browser. ChatGPT has a browser now, and now Perplexity has a browser called Comet. So if you want an AI assisted browser, you can actually install that as well. I have it, I just don't use it. I still use Google. I'm still used to using Google, but generally speaking, I typically use Perplexity most of the time for most things. This is a subscription, right? It's not local, it's a service. The other service that I use too is N8N, N8N.com. Let's see if I go there. And I actually have an account here. I actually host N8N. This is my workflow, AI automation workflow solution that I use. I actually use N8N locally, but I also use it as a SaaS solution as well. One of the things that I like to do is tie in multiple services. So, for example, I like to tie in. I don't know if I can do that because I think my my account is locked. Yeah, there's no workspace. So I used to have a workspace here, and I used to have a a workflow where I would go to 11 labs. So basically, creating a customer service assistant, right? Am I logged in here? 11 labs. Let me see my agents. So here I have a Nutanix agent, right? This Nutanix agent basically called N8N when it went to schedule an appointment. So you could call this agent. It had access to all the Nutanix website, just a website for now, right? And I could ask it any question, or I could get information from the website. And then I would say, hey, this sounds great. I'd love to be able to speak to somebody about this. And then the agent would create a appointment with the account team. And the way it did that is it would call N8N and use local models, right? Instead of going out to and using a foundation model or a frontier model service, right? Uh, OpenAI or some other model, right? And having me pay for that API hit, it would use a local workflow to actually schedule the appointment, and then it would use an agent to tie back in to my Gmail calendar, et cetera, and send the user the appointment through an email, right? So again, just something that you could think about hybrid AI for, right? The ability to leverage a service, then tie that back into an on-prem solution and really have a hybrid AI approach where you're using the bulk of what you need 11 labs for, which is the voice piece of it, right? and the agent piece of it, acting like a customer service agent, but the actual scheduling of an account, or sky's the limit. You can think of all the possibilities. You can pass that off to an on-prem solution where you don't need to pay for using a frontier model service as an example, right? You can do it on-prem. So the ability to kind of tie those two together really shows a lot of power there in what you can do. But these are some of the tools that I use. Like I said, 11 Labs for voice agents, Perplexity for my overall global AI solution, Warp for my terminal, which has AI assisted agents built in, Visual Studio Code tying back into Continue for programming locally without having to pay GitHub Copilot. So, tying this all together, right? What does it mean? Well, it means that you can build a system, right? Whether it's local on your desktop, which I showed you, or it's in a kind of a pre-configured lab, small lab that I had, the DGX do-it-yourself DGX Spark, for lack of a better term, or buying a system like a DGX Spark, right? Like going to, and actually buying a purpose-built system like a framework or DGX system, or even a Mac, right? You have all these options and choices to actually leverage for yourselves when it comes to your local AI. So again, I hope this uh, uh, was good for you guys to actually look and see what's out there. I know when we looked at the prices for like enterprise gear, they're astronomical. Honestly, right now, I would hold off on any enterprise gear unless you get a deal on something, um, or unless you need that PCIe bandwidth I was talking about. I mean, if I were to build something today, I probably would use commercial grade solution, or an older Epic system, or older Threadripper system, motherboard, and maybe 24 core Threadripper or something like that, and take advantage of all those PCI lanes, and then buy two 3090s, and now I have 48 gigs to leverage for my models with phenomenal bandwidth. And I'm only spending so much, right? If you're looking for something small form factor, you can do what I did and build something like I did, or you can go ahead and buy a framework or a DGX Spark, or even a Mac, an M3 Mac Mini that has the ability to, the M3 Mac Mini is very expensive when you get up there in the high memory. It's actually more expensive than the Spark, actually. Or excuse me, yeah, the Spark. So I would probably just buy the DGX Spark before I went M3 Mac Mini, or unless you're like me, you have a platform, a workstation that you want to use for everything, right? Where you don't want to have a separate server or separate home lab environment. I want to use my workstation. I want it to be um, uh, very flexible in the use cases, right? For my workstation, for my work, my daily work, for play, like I'd use for gaming, for AI, etc. You have the ability to kind of have one platform to do all of that. And that's why I think most people don't look at that yet. I see still a lot of people that have like, oh, I have this desktop PC, or I had this workstation, and then I go buy something. You don't have to do that, right? Your home lab could be right in the workstation that you're using. And you can segment environments out, right? You can run on your home lab, right? On this station, I can run Linux, right, alongside Windows, and I can run Olama on the system and kind of have it separated a bit from what I'm doing daily, and not have it kind of affect what I'm doing at work. So, for example, if I'm working during the day and I need to do something with Visual Studio Code, that I can run Olama and run CodeLlama and tie it into Continue in Visual Studio Code and still be able to function, do my email, have all my Chrome windows, my 100 Chrome windows up, whatever I'm doing, PowerPoint presentations, or I'm doing coding or whatever, I'm able to do that on one system, right? And I think, honestly, there's something to be said for that. You don't have to go out and buy extra things, right? You can leverage what you have. And so think about your use cases. Think about, the things we went over today, and things that you can do. I apologize that the NIM model didn't work on my DGX Spark. I have to look into that. It was working fine before I did this, of course. Of course, that's what happens with live demo, right? But you saw Llama working on that, no problem. I'll get the NIM models working again, no problem. Not really worried about it. But the ability to run both of those, right, in one platform is very powerful. And again, you don't have to spend a ton of money to get started. So I hope this was useful for you guys, and I hope you enjoy the rest of your Thanksgiving holiday for those of you who are celebrating that. And I wish you a great holiday season. Stay tuned for more content. We'll have more content on the blog, and of course, upcoming podcasts as well. So I hope you have a great day today. Thanks again.